For those of you who know Henry well, know that I'm not Henry. I'm the co-author on the paper, Gene Wahl. Let me think for just a second. Sorry for needing the chair here, but I have trouble with one of my feet, and I can't stand in one place for long periods of time. So we're going to talk to you about work that we've been doing with regard to reconstructing precipitation in Western North America, and what we've done is we've extracted from that spatially explicit work into looking at the current California, or I should say the just past California dryness. Where's the next slide? Okay. So here's the situation that all of you are quite familiar with. Over on the right is the 2014 water year ending in September 30th, and you can see that it's actually not the driest year. Even in the instrumental record, it's the third driest. 1924 is the driest in this area, and that shows up significantly in our reconstructions as well. But I just want to get us familiar with this, and also with the fact that what does make the just past situation unusual, or nearly unusual, is that the 3 years in a row had essentially a loss of one entire water year's precipitation, which was the driest 3 years of that kind in the instrumental record for that area. Although centered on 1930, that 3-year period was very much nearly the same. So we're going to come back to this again as we go through the reconstruction. Just to give you a feel for the area that we're talking about, it's most of California and about half of Nevada, so we call it CANV, California plus Western Nevada. And here's the time series then. The reconstructed values are the gray, and then you can see the heavy smooth. That's about a 10-year locally weighted regression smooth. The blue and the salmon color are the instrumental data, two different flavors of that in terms of the full EOF component for the instrumental data and then the truncated EOF basis that was used in the reconstruction itself. They track with each other extremely closely, and you can't see it exactly quite so well in this diagram, but we'll be going through some of the characteristics of the reconstruction before the interpretation. The tracking with the reconstruction is quite excellent as well. One thing I want to point out here is one of the motivations for this was the Pages 2K project, and in particular the second part of that, trying to push back spatial precipitation reconstructions in each of the continents and the ocean as far back in the last 2,000 years as possible. Second thing I'd like to point out is that the reconstruction technique used here is what's called principal component spatial regression using a truncated EOF basis. And the predictor variables here are not direct tree ring chronologies. They are actual streamflow reconstructions, 14 important streamflow reconstructions from the western United States. And that turns out to actually to have some nice characteristics that we exploited. So to give you a feel for the quality of this time series, here are some of the typical validation and calibration statistics. You can see that the explained variability is extremely high, both in calibration on the left there and in validation. This is about as good as it gets for this kind of reconstruction, so we feel very good to make interpretations based on this. A little bit more about the quality of the reconstruction. You can see the reconstruction versus actual there over on the left, and that's almost like a textbook kind of diagram where the reconstruction just follows the actual very tightly along the one-to-one line there. And over on the right you can see the plot of the residuals in terms of the reconstruction across the spectrum of the reconstruction. And this shows a very kind of what we would call homoscedastic pattern, which is a desirable characteristic. Same thing here in terms of the time series of the residuals, and if you do the Durbin-Watson test, the p-value is 0.98, meaning a robust failure to reject the hypothesis that there's no AR1 autocorrelation here, which is also a very nice feature for the residuals. This is an interesting characterization here. This is what's called a persistence length characterization. So persistence length was defined by Bunde et al. In a paper from last year where they asked some interesting questions. And what it means is the number of years in a row where the variable of interest is either above or below the median sequentially. And you can see that here, that only happens, the longest period in this 450 or so year reconstruction, there's 9 years in a row where that happens. Now, what's of particular interest here, if you look on the left, in the upper left here, this is the main diagram from Bunde et al. They have 3 different long tree ring driven precipitation reconstructions from Pakistan, Colorado, and Central Europe. So 3 different continents in different semi-arid areas. Well, 2 semi-arid areas and one wet area. And then you can see below that on the left in panel C there, synthetic data that are by design have long-term persistence, meaning you can get decadal runs in a row. And so you, in this semi-log diagram here, you can see this sort of hockey stick-like shape, as it were. And what they point out in this article is that if you look at observational data from these areas and if you look at model data over these areas, you don't see that characteristic. And the question that they were asking is this some sort of biological artifact that in terms of the persistence that's actually being driven by the biology of the trees more than it is climatologically? They don't actually answer that question, but they say it's an important question to ask. And we're just noting here that if that is a problem, it's not a problem in our reconstruction. So, to go on, this is a spatially explicit reconstruction, and here you can see the year 1924, the instrumental on the left, reconstruction on the right. And I wanted to highlight there's 4 particularly strong years in this reconstruction that are similar to what we just went through, and they're on the bottom there in chronological sequence. The pattern congruence over that California-Nevada area of the reconstruction and the instrumental is 0.97 on average. Incredibly high. So we feel like we have, extracting that part of the domain and looking at it, we have a really strong product here for interpretation back in the past. Here's the histogram then of those pattern congruences for that region. The median is 0.86. Now there's some clinkers here. There's some that are below 0, but this is anticipated. But if you think about it here, then it means if we're really looking at the extreme dry years, we're on a really solid basis here to make evaluation. And here are the spatial field characteristics in terms of these measures of merit. And again, these are very high marks for a spatial reconstruction. There's 224 individual half-degree grid cells that are involved here. So now to interpretation. So there's 6 years here, and they're denoted by the arrows in the pre-instrumental period, meaning before 1895, that have characteristics much like the year just passed here in California and western Nevada. And so and then there's 3 other years in the instrumental period. So there's essentially 9 years that are similar to what we just had. And given that this is roughly a 450-year period, we're saying on average, we're not talking about a formal return interval here, but just on average, roughly every half century there is something like this. So one of the big take-homes here is that although this was an extreme situation, it's not at all unprecedented. And this is an independent confirmation of the precipitation results from the Griffin and Anchikaitis article that was just published a couple weeks ago. I had a chance to talk with Kevin Anchikaitis himself this morning, and we did confirm that the chronologies that they use, the 3 or 4 blue oak chronologies, we weren't 100% certain that none of those are involved in this reconstruction. But even if all of them were involved, it's like 2 orders of magnitude less information than what we have that's driving this reconstruction. So this is virtually independent. And we were even talking specific years like, what about 1841? Or what about 1580? And it was very exciting to be able to do this. So we're really looking forward to this coming out. It's in review with Journal of Climate right now. Here's the histogram then of the precipitation reconstruction. And you can see it has this skewed more or less unimodal distribution. As might be expected, it's the wet years that can really get out into the extremes because they're not bounded by 0 on the side. And you can see that there are a number of years in the 19th and 20th centuries where you have high values for the precipitation, sometimes almost approaching 1983 and 1997, which you can see over there on the far right of the highest peaks there, which are these big El Nino years that we're familiar with. And just to tease a little bit here, it looks like there might be something of a regime change in that regard in terms of the extremes on the wet side, somewhere around 1825. And this is an unevaluated feature of this reconstruction right now. We're just noticing it. Okay, now in terms of these 3-year periods, again, this is the graph I showed you earlier, just for to refresh your memory, and now in comparison with the reconstruction. By the way, the reconstruction ended in 1997 because one of the big important streamflow reconstructions that we used of the Sacramento River by David Miko, it ended in 1997, so that constrained us in that particular way. So you see the 1929 through 1931 event there in the blue ellipse on the right. And there's 2 other times where we see essentially the same deficit over a 3-year period. So again, the take home here is that this is an extreme situation that we've just passed through. But again, it's not at all unprecedented. Is there a problem? Oh, okay, wrong room. Okay. So that's, here we're talking about 3-year runs like this, maybe on the order of, just on average, not a formal return time, of once a century or so. Okay, to take a little bit of time quickly here with just the spatial aspect of the reconstructions, which again is a somewhat unevaluated component of all of this, because we've been focusing so much just on the California-Nevada time series per se. But you can notice there's sort of 2 basic flavors in the instrumental period for these most extreme dry years in California and Nevada, where you get a sort of pan-western drought, like you see on the bottom there. And then you get something that's more focused on the west coast and immediately inland from the ocean, as you see on the top. If you look back further into the Reconstruction, you see those same kind of droughts. You see the kind of pan-regional one or something near to that, upper right, and more coastal-oriented and near inland region below. But you also see flavors that don't actually occur in the instrumental period, and you see that for 1571 in the upper left, where the entire Southwest is involved, along with the West Coast. So this is, again, is something that Henry and I will be exploring in greater detail. Finally then, here is the geopotential height anomalies for 700 hectopascals for the last water year just ending at the end of September, and then for the average of the 3 years leading, that includes that starting in 2012. And you can see this giant ridge of high pressure off the west coast, which is the proximate feature that leads to this extreme dryness. And it stands to reason that you would expect to see something like that into the past. But we have now objective information to confirm that hypothesis. And this is based on some work that I've been doing with Eduardo Zurita in HZG Institute in Germany. And we're using a model analog process driven by the NADA and also by a winter temperature reconstruction that I published with Jason Smerdon and Henry Diaz and Casper Amann. And so I'm going to show you the winter sea level pressure reconstruction for these 5 driest years, which are now not in chronosequence, but in terms of intensity sequence. And these are the reconstructions, and you see the exact same sort of thing where there's this large ridge of high pressure, and it seems to be a predominant feature, at least of the half millennium, for this kind of dryness to have occurred. Okay, so last slide here. So we've made the case that while this is an extreme situation, it's not unprecedented, but there are 2 aspects that are unprecedented. One is, since the temperatures have risen, the actual drought intensity, and here we're measuring it by the SPEI, is unprecedented. And Griffin and Anchikaitis showed this with their extension of the NADA PDSI for their reconstruction region, that it was the driest year according to that metric in the last 1,200 years. And also, there's a whole lot more people here in California and western Nevada than there ever have been before. So it is extreme in that situation. And with that regard, I'd just like to end by saying thanks to Ed Cook for helping consult and think about this, and also to Jeff Lucas for his help with identifying the stream flows to use. And with that, I'll take any questions. Thank you. Jason. Which pattern are you referring to?
We're looking at the drought patterns in Reconstruction.
These guys? Yeah. I haven't gone back and looked at these in relation to the EOFs. Of course, they have to be some combination of them, because that's how the reconstruction works. And that's, again, part of the analysis that we're going to be looking at. So I'm sorry I don't have an exact answer to your question. Other questions? Be happy to answer questions. Thank you very much.